this one, in this section, we'll be factoring a trinomial, specifically x squared plus bx plus c. Later, we'll be having some coefficient a other than 1 in front of x squared, but now it's x squared plus bx plus c. All right, now we can factor this x squared plus bx plus c into a product, x plus p times x plus q, if p and q add up to b, and p times q multiply out to c. If you expand this, you get x squared right here, plus px plus qx, which should be b if p plus q equals b, and then last term is pq, which should be c. So we need to find, given this, we need to find two numbers which add to b and multiply to c. Now, the thing is that what I've often seen is people just they try and look and they stare and try and immediately find the solution by inspiration. That puts too much strain on the brain. It doesn't always work. What you want to do is create a system which does the job. And the system is you look at the factors of c, given p and q has to be c divided by p, and see if those two factors add sum to b. So, for example, x squared plus 5x plus 6. We want whatever p is, q has to be 6 divided by p, and then we look at their sum. And so we try various values of p. If p is 1, then 6 over p is 6, they sum to 7, no good. If p is 2, then 6 over p is 3, and they sum to 5, and that's good. So we'll use x plus 2 times x plus 3. T squared minus 14t plus 48. All right, their product must be 48, and the sum must be 14. Just a moment. 622. All right, so we look at the various factors of 48. Whatever p is, q is 48 over that, and we look for the sum. P is 1, q is 48, the sum is 49. Too big. 2, 24, sum is 26, closer but not there. 3, 16, 19, not there. 4, 48 over 4 is 12. 4 and 12 is 16, almost there. If p is 6, then 48 over 6 is 8, and these sum to 14, and there you go. So we put 6 and 8 here and here. This equals t plus 6 times t plus 8. Here, we want y squared minus 18y plus 72. Well, we need two p and q whose sum is negative 17 and whose product is 72. Now, an interesting little flip happens in the search here. We start with p equals 1, q is 72, their sum is 73, which is not only the wrong size, it's also the wrong sign. This should be negative, here's positive. The remedy is to flip everything. Negative 1 for p, so q is negative 72, and the sum is negative 73. Still too big, but at least it's the right sign. Then you try negative 2 for p, doesn't work. Negative 4 for p, doesn't work. Negative 6 doesn't work. Negative 8 works. The p is negative 8. 72 over negative 8 is negative 9. These sum to negative 17 as required. So we'll put those in here. Y minus 8 times y minus 9 is the factorization. Before I go on, remember, the reason why we're doing factoring is to solve equations. If we have the equation this equals 0, then that means that this product equals 0. And there's a rule which says that if a product equals 0, then one of the factors is 0. So then you can solve for the values of the possible solutions of y that way. We'll get to that later. Okay. Z squared plus 7z plus 12. P and Q have to add to 7 and multiply to 12. 3 and 4 work. 3 plus 4 is 7. 3 times 4 is 12. So this equals z plus 3 times z plus 4. T squared minus 11t plus 28. Need two numbers whose sum is negative 11 and whose product is 28. You try 1, then Q is 28, and the sum is 29, which is the wrong sign. So we flip all the signs. Negative 1, negative 28, negative 29, doesn't work. Negative 2, Q is negative 14, sum is negative 16, doesn't work. P is -4, Q is 28 over -4, which is -7. These sum to -11, which works. That's what we're looking for. So we get T minus 4 times T minus 7. All right. X squared plus 5x minus 24 is what? We need two numbers whose sum is 5. This product is -24. Again, we're winding up with a, we're going to wind up with a flip. If P is 1, then Q is -24 over P, which is -24. Sum is -23, which is the wrong sign. We want a positive. This is negative. So we flip everything. P is -1, then Q is positive 24, and the sum is 23. Doesn't work. If P is -2, then Q is 12, and the sum is 10. Closer, but not there. If P is -3, then -24 over -3 is 8. -3 and 8 is 5, and that works. So we get x minus 3 times x plus 8. And that's the factorization. B squared minus 9b minus 36. Okay, sum is -9. Product is -36. So P, Q is -36 over P, and their sum. P is 1, Q is -36, sum is -35, not quite. P is 2, Q is -18. Oh, no, really? This should be a 16. 6, 2, 4. Again, but however, that's no good, isn't it? P is 3, Q is -12, sum is -9, works. So B plus 3 times B minus 12. A squared minus 5ab plus 6b squared. This is a little different because you have this b here and here. Well, it's almost the same though. Again, we need P and Q. Their sum is -5. Their product is 6. P, 6 over P, sum. P is 1, Q is 6, their sum is 7. Wrong sign. So we change to negative. -1, -6, -7, not quite. -2, -3, sum is -5, quite. So this will be A minus 2B, to account for these, times A minus 3B. So these B's here and here, means he put B's here and here. A squared minus 4A minus 5, this is a pretty quick one. The sum should be -4, the product is -5. 1 and -5 work fine, so you can get A plus 1 times A minus 5. Here's a cute one. R squared minus 2R plus 4. P and Q have to sum to -2, and their product has to be 4. So P, whatever P is, Q is 4 over P, and then we look for the sum. 1 for P gives you 4 for Q. The sum is 5. Wrong sign. -1 for P, -4 for Q. Sum is -5. Not quite right size. -2 for P, -2 for Q. Sum is -4. And then if you keep on going up for P, -4, Q is -1, you go back to -5. And in fact, -2 has been skipped. It's not happening. There's no way to do this. So therefore, this is not factorable. It's a prime. It's prime. Same thing is not factorable. Now this one, the problem is there's a 2 in front of the x squared. And this method only works for a 1 in front of the leading coefficient. But fortunately, 2, 12, and 6 all have a common factor of 2. So we remove a common factor of 2, and we get 2 times x squared minus 6x plus 8. So we need to factor this. P and Q has to equal -6. P times Q has to be 8. 1, 8, and 9 doesn't work. -1, -8, -8, and -9 doesn't work. -2, -4, and -6 does work. So we have 2 times x minus 2 times x minus 4 is the solution. Uh, 103A and B, similar problems. x squared minus 10x plus 24, and x squared minus 10x minus 24. I'm going to go through this in fuller detail. Okay, the sum for this one, the sum P and Q has to be negative 10, and their product has to be positive 24. So we have P, Q equal to 4 over P, and then we look for this sum. If P is 1, Q is 24, the sum is 25, wrong sign. All right. If P is negative 1, so we flip the signs, negative 1, negative 24, negative 25. Not quite there. P negative 2, Q is negative 12, sum is negative 14. It's closer. P is negative 3, Q is negative 8, sum is negative 11, closer still. If P is negative 4, then 24 over negative 4 is negative 6. Negative 4 plus negative 6 is negative 10 as required. So you use x minus 4 times x minus 6. That's the factorization. Now here we have x squared minus 10x minus 24 instead of plus 24. So the sum, P and Q, is still negative 10, but now the product is negative 24. So what P, whatever P is, Q is negative 24 over P, and we look for the sum. Q is 1, Q is negative 24, sum is negative 23, no good. If Q is 2, P is 2, then Q is negative 12, sum is negative 10, good. So we get x plus 2 times x minus 12 is the solution here. Okay, that should do it.